Hello, Geometry. Welcome to 3.5. Fast from the past. I can find the slope of line segments. I can identify parallel and perpendicular lines. And I can use this in the real world. Alright, so a little bit of a warm-up. Evaluate. And if you'll notice, this is kind of like the slope formula, hence our topic of the day. Substitute in. A is equal to 5, B is equal to 2, so 5 minus 2 over C minus D, which is 1 minus 7. 5 minus 2 is 3, 1 minus 7 is negative 6, that will be reduced to negative 1/2. Okay, so simulating the slope formula. Remember change of y over change of x? Alright, how about solve? Whenever you see an equal sign, you have a proportion. Cross, multiply, and solve. Okay, so 3 minus 4, which is negative 1 times 1, is equal to negative 1. And then 5 times that quantity, x minus 3. So I'm going to go ahead and distribute 5x minus 15. I want to add 15 to both sides. 5x is equal to 14, then divide by 5. Don't be afraid of that improper fraction. Remember, this could define a slope, up 15 over 5, up 15 over 5, etc. All right, reciprocal. This is important because when you are finding perpendicular lines, you'll find the opposite reciprocal. This is just the reciprocal. So the reciprocal of negative 3/4 is negative 4/3. Okay, the negative stays if you want just the reciprocal. If you want opposite reciprocal, that sign will change. All right, JD was thinking of a number, or Andrew, and the product of the number, is 5 and negative 1. What was Andrew's number? Oh, the product of the number and 5 is negative 1. So we have the number x times 5 is equal to negative 1. So the product of the number and 5 is negative 1. So to get x by itself, divide by 5. You're going to get x is equal to negative 1/5. So think about it. 5 times a negative 1/5. What will those 5s do? Cancel, you get negative 1. Okay? Gotta be careful with my reading and typing. Key concept. Slopes of a line of a coordinate plane. Remember, slope is rise over run. Delta y over delta x. The Greek letter delta means change. Change of y over change of x. So y2 minus y1 over x2 minus x1. Also, you could do this. y1 minus y2 over x1 minus x2. Just make sure the corresponding pairs are right above and below each other. A couple formulas to define your slope. If you recall, this is a positive slope, negative slope, zero slope, undefined slope. So not very steep, a little steeper, very steep, and the most steep, I guess. All right, here we go. So find the slopes of lines. Of course, they want us to use the formula, and I'll write down the order pairs. It's kind of hard to tell, so just bear with me. Let's see here. This looks like negative 7, 2, and negative 3, 4. Recall the slope is change of y's over the change of x's. Remember, what does negative negative mean? So I have a negative 2 over negative 4. That reduces to 1/2. Negative over negative is positive. All right, not too hard. B for Bob. So B is this line right here. It looks like I have the point 24. And 6, negative 2. Find the slope. Let's see here. Put the y's on top. 4 minus a negative 2. X is in the bottom. 2 minus 6. You get 6 over negative 4. That reduces to negative 3/2. Again, do not change this to a mixed number. C is for cookie. Okay, so the points for C, that looks like -4, -6, and 3, -6. Change of y over the change of x. Remember, negative means positive, so -6 plus 6 is going to be 0 over -7, which is still 0. It's a horizontal line. Horizontal lines are 0 slope. And last but not least, you should know the answer for D. The 2 points appears to look like -7, -3, -7, -5. Change of y, -3 minus a -5 over -7 minus a -7. So this is going to equal 2 over 0. You cannot divide by 0. If you are confused, always grab a calculator and take 2 divided by 0 and see what happens. Okay, so it's undefined. So far, so good? Alright, let's go to the next page. Playing with slope. Alright, so the top of this page, slopes of parallel lines. Parallel lines have the same slope. So if you look at this one here, the slope, remember y equals mx plus b. The slope is 2 over 1. And how about this one? The slope is 2 over 1. So that's our slope. And that's our y-intercept. So parallel lines have the same slope. All right, how about this one? Perpendicular lines. Usually you use this symbol for perpendicular, this for parallel lines. Okay, so in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. So basically they have to be opposite reciprocals. So if I take slope from line 1 times the slope from line 2, it equals -1. So i.e., example, let's say slope of m1 is 2/3, and the slope of m sub 2 is -3/2. If I multiply them, what's happening here? 2's cancel, these cancel, you're going to get -1. That negative's still there. So if they're opposite reciprocals. Alright, find the slope of each one. Okay, I'm just going to go ahead and use the pictures. So if you have the graph of it, that's a lot easier. So to find the slope, to go from this point to this point, you always want to go left or right. Do we have to go up or down? Down. How many? 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. Please always reduce your slopes. B for Bob. To go from here to here, I have to go down 1, 2, 3 over 1, 2, 3. And C for Cookie. This point is kind of hard to see. Go down 1, 2, 3, 4 over 1, 2, 3. None of them are parallel. Alright, so don't let that confuse you. Ooh, this next one. Okay, line K passes through the point. Oop, gonna need a straight edge. 0, 3, and 5, 2. Let's draw that bad boy. Label that K for Cookie. Let's find the slope. Remember, change of y. Oop, you can't see that. Change of y over change of x. 1 over -5. Okay, so we want to graph a line that's perpendicular to K but passes through this point. Well, if this is my slope here, the perpendicular slope is going to be 5 over 1. And it's got to pass through the point 1, 2. So from here, I'm going to go up 5 over 2. Oops, sorry, not over 2, over 1. Hee hee hee. I'm like, that doesn't look right. And let's connect. Actually, I'll go down 5. 1, 2, 3, 4, Or we'll go in the other direction. Because I wanted to point out that point. It has a special name. Okay, so let's look at this equation right here. Y equals mx plus b, and we know the slope was down 1 over 5. So y equals negative 1 over 5x, and across a positive 3. Now how about this one? This is our perpendicular k. Y equals, the slope is up 5 over 1, and it crosses at negative 3. I guess I didn't need to put plus or minus 3. Okay. It only asks us to graph the line. It didn't ask for the equation, but I always find that helpful. All right. Andrew drained water from old tanks at 3 farms before installing new tanks. The graphs show the amount of water in each tank from the time the water began to drain until the tank was empty. Which statement is true? Okay. Tanks all began draining at the same time. Well, no, they're at different farms. I mean, it'd be impressive if you can do that at all 3 farms at the same time. Okay. Tank B was empty 4 minutes before tank C. Okay, B is right here, C is right here. Times in minutes, nope, 1 minute. However, if you look at the difference between B and A, 1, 2, 3, 4. So B drained 4 minutes before A. See, this is the amount of water. They're all draining. They're all going down. Tank C drained at the fastest rate. Okay, so let's find each one. Slope of A. Okay, the slope of A, we're starting at, looks like 600, down 600 over 1, 2, 3, 4, 5, 6, 7. Which is about negative 85.7. I know you're probably wondering how I got that. How about slope B? Okay, slope B, we start at 500, down 500 over 3. Which is about negative 166.67. And slope C, down 900 over 4, which is negative 225. So which one is draining the fastest? This is my steepest slope, so tank C. Yep, that's true. And then look at the last one. Tank A is larger than tank B. This just says the amount of water. It doesn't tell us anything about the tank size. So tanks might not have been full. But tank A did have more water than tank B, but we don't know the size of the tanks. Okay. Moving on. All right. Here we go. We're almost done. A candle is lit at the center of a table at the beginning of a party hosted by Jacob. Did I change that? I don't know. Height decreases by 1.75 inches every 25 minutes. At the beginning of the dinner, the candle was 8 inches tall. So make a table. Time in minutes. So we'll do 0, 25 minutes, 50 minutes, 75 minutes. Okay, so the height in inches, we'll start off at 8. So it's going to go down 1.75. So if I take 8 minus 1.75, I'll get 6.25. So after 25 minutes, that's how tall it is. That's a bad 5. And then subtract another 1.75, you get 4.5 after 50 minutes. And then subtract another 1.5, you have 2.75 after 75 minutes. Okay, I've got enough points. I can move on from there. Alrighty. Write a fraction that represents the decrease in height for each minute the candle burns. What does the numerator represent? Okay, so basically we're finding slope here. Let's just pick 2 numbers. We'll do these 2. So change of y. This is like my x, this is my y. 6.25 minus 4.5 over 25 minus 50. So I have negative 1.75 over 25. Oop, this is the negative. So when I divide those out, I'm going to get a negative 0.07 over 1. So when I divide that. So the reason why I had to take this divided by that is because they want it for each minute. So it's going down, the negative means it's going down 0.07 inches for every minute. So that's what the numerator means. Okay. The stick candle is replaced with a thinner candle when dessert is served. It burns with the slope much faster. It's going down a half an inch for every minute. Okay, and it starts at 5. Well, use a graph to compare the way they burn. Okay, so the first candle is in inches. It starts at 8. So he's 8 inches, the 0.08. And then I know at 75 minutes it's going to go down 2.75. So here, let's do this. 25 minutes, 50 minutes, 75, 100. So at 75 minutes, it went to 2.75. So 2.75 will be right about here. Connect. Obviously, this part of the line doesn't make any sense. Okay. Now, the next candle, it starts at 5 inches. And it's going to go down 0.5 for every one. So if this is 25, it's about 12.5. 0.5 for every one. It's going to be really close here. What's happening? Actually, it should be even closer. Alright, so this is my first candle. We have this 0.75, 2.75. And then here's my second candle. And it went down a half inch, so 1 and then 4.5. So it's kind of hard to do. Well, which one's steeper? Obviously this one. This is steeper. It's going down a lot faster. Okay? So our homework assignment, obviously I had intentions to give you another one, decided not to. And there's your standard. Everybody have a nice evening. Enjoy the weekend.